Let's look at this set. 9 friends, namely Ajay, Biswa, Chetan, Danny, Isha, Faizan, Guneet, Hansika, Ishant, decided to play a game of cards, Satte Pe Satta, in which each player has to pick one of the 9 cards lying upside down on the table. Each of the 9 cards is one of the 3 colors, namely red, green, or yellow. Exactly 3 cards have the same color, and each card has a distinct number written on it, which is a multiple 1 to 9 of 7. So the 9 cards that we have will start at 7, 14, 21, and 28, 35, 46, 42, 49, 56, and 63. These are the 9 cards that are available. The total of 3 cards of each color make an arithmetic progression with a common difference of 14. Now see, given that these are multiples of 7, these multiples of 7 don't really make any huge difference for us. These 7s are of no utility to us. We can actually write it down as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we are told that total of 3 cards of each color make an arithmetic progression with a common difference of 14. I'm saying color 1, color 2, and color 3. Their summation should make an AP with a common difference of 2, not 14, 2. Because every card is a multiple of 7, right now they're saying 14, but it actually means 2 because you have to divide it by 7 if you're dealing with these numbers. All right, I'm not sure everyone would be comfortable dealing with these numbers. So the difference is of 14. I'll work with that. Let's add these numbers up. We get 70 into 4 plus 35. So 315. These numbers add up to 315. So the 3 colors, because they are in AP, the middle term will be 105. 14 more than this will be 119. 14 less than this will be 91. The 3 groups will have summation of 91, 105, and 119. Okay. It was known that 5 cards, assume with numbers A, B, C, D, E, such that A, B, C are in geometric progression with an integer common ratio. And these cards are of different colors. This is true for cards with numbers A, D, and E also. Okay. The simplest work around here would be, see, 7, 14, 28, and 7, 21, and 63, with the common ratio here being of 2 and the common ratio here being of 3. This is known. Now we are also told these 3 cards, 7, 14, 28, and 7, 21, 63, are in different colors. So I'm saying let 7 be here, 14 be here, 28 be here, and 7. Now 21 and 63 have to be paired up. These 2 numbers, either 21 will come with 14 or 21 will come with 14 or 21 will come with 28. First case I'm trying, let 21 come with 14. If 21 comes with 14, right now it adds up to 35. It adds up to 35. Even if it adds up to 35, if 21 comes here, 63 comes here. So far the summation here is 35. So far the summation here is 91. Okay. Now this 35, if I wanted to reach a total of 91, I need to add a 56. I cannot make it reach a total of 105. I cannot make it reach a total of 119 because the largest available number is 56 only. So I add 56 to this and I reach a total of 91. This possibility exists. On the other hand, here, after I've reached 91, of course, one more card is coming in, so 91 cannot be reached. Can I add 14 here? No, 14 is already used up in this group. Can I add, if 14 can't be done, can I add 28 here? Can you see? From 91 to 105, you need a 14, which is not available. It was used in the other group. From 91 to 119, You need a 28. You cannot have that card because 28 is already used up in this group, which means this third group cannot be created any further, which means our initial assumption of pairing up 14 and 21 itself was faulty. We can't have that. 14 and 21, 14 and 21 cannot pair up. So 14 and 63 have to pair up, and 28 and 21 have to pair up. Right now, the summation is of 77. Right now, the summation is of 77. The summation is of 49. Now, 77 to 91. 77 to 91. 77 to 91 will need me 14 more, and 14 is unavailable. I can't go. 77 to 105. 77 to 105 will need 28 more. Can't use that. It is already used up in the other group. 77 to 119 will need a 42. And yes, that is available. So I can add it up 42, and this adds up to 119. Okay. Here, 28, 21. I've already reached 49. In order to reach 91, I need a 42, which is not available. In order to reach 105, I need a 56. In order to reach 105, I need a 56, which is possible. And I can't reach 119, that is already done. So I can't reach 91. I can't reach 91, 42 is used up. The only thing that I can do is add a 56 here, and we reach 105. And the numbers that are left, 7, 14, 7 is used up, 14 is used up, 21 is used up, 28 is used up, 35 will come here, 42 is used up, and 49 will come here. We get to 91. Okay, so the three cards here are 7, 35, and 49. And the three cards used up for 105 are 21, 28, and 56. And the three cards used up here are 14, 42, and 63. The three groupings are known. Three groupings are known. Okay. I can get rid of these also now. So far, we have read through this portion only. So far, we have read through this portion only. Next, we are told sum of any two red cards taken together was not equal to the sum of all the three cards of any other color. Also, sum of all three red cards was not equal to sum of any two cards of any one color. Which is to say, first thing I should do is sum of two cards taken for each group. From the first group, the three summations I will get are 42, 56, and 35, 49. Adds up to 84. This is sum of cards taken two at a time. Here the summation will be 49, 77, and 84. Here the summation will be 56, 77, and 105. Sum of two cards taken at a time. Now the instruction was sum of any two red cards taken together was not equal to the sum of all three cards of any other. The only summation where this can happen is 105. So this cannot be red. Color 3 cannot be red. Additionally, we are told also sum of three red cards was not equal to sum of any two cards of any one color. Which is to say this 105 also cannot be red. This also cannot be red. So if C2 cannot be red, C3 cannot be red. This has to be red. This is known. This is known as a guarantee. Don't have to write this down separately now. Next thing. This point is taken care of. Next. The highest possible difference between the highest and the lowest card of any color was not for yellow. The difference between the highest and the lowest card for here would be 35. And the difference between the highest and the lowest card for this color is 49. We know 49 is the highest, and this is not for yellow. This is not yellow. This has to be yellow. So this has to be green. These were the only three colors. We have also uniquely identified which set of cards belong to which color. Point 2 is taken care of. Now the last point. Ajay Biswachetan had some colored cards, had the same colored cards but not green. So Ajay Biswachetan can be red or yellow. Danny, Ishan, Faizan had the same colored cards but not red. So Danny, Ishan, Faizan could be yellow or green but not red. Guneet, Hansika, Ishan had the same colored cards but not yellow. They can't be yellow, they can be red or green. Okay, so let's make cases out of this. We could have Ajay, Biswa, Chetan here. They are not green. Now Danny, Isha, Faizan had same colored card but not red. They can't be red. But Guneet, Hansika, Ishan were not yellow. So Guneet, Hansika, Ishan could be here. And by extension, Danny, Isha and Faizan are left here. This is one case. But this is not the entirety of it. The other case could be, we had started off with Ajay Biswa Chetan being in red. This time let Ajay Biswa Chetan be in yellow. Ajay Biswa Chetan be in yellow. I know Danny, Ishan and Faizan were not in red. So Danny, Ishan and Isha and Faizan are in green. And therefore Guneet, Hansika and Ishan were in red. These are the only two possibilities. Let's get to individual questions. Which of these cannot be the difference between the cards of card numbers of Biswa and Chetan? Can I have a difference of 28 for Biswa and Chetan? For the second case, if they have 56 and 21, they can have a difference of 28. So this is out. 14. For case number 1, 49 and 35, they can have a difference of 14. Can they have a difference of 7? For case 2, 28 and 21, Biswa and Chetan can have a difference of 7, but they can never have a difference of 21, and therefore that should be the answer. Okay. Another way of potentially doing it, if I write down my numbers again, difference, no? Okay, sum is also tested here, difference is also tested here. So I'll write down all possible summations first. 42, 56, 84. Here the summations will be 49, 77, 84. And here the summations will be 56, 77, and 105. These are the three summations of cards taken two at a time, and differences would be 28 and 14 and 42. Here the differences will be 7 and 35 and 28. How did I get 28 as a difference? Okay, 35 minus 7, I got 28. Here the differences will be 28, 49 and 21. These are the possible differences. These are the possible summations. Now look at it. Biswa and Chetan. Biswa Chetan here, they can get 28, they can get 14. Here they can get 7. But for 21, they would have to be within the green grouping. And I know Ajay Biswa Chetan were never green. Therefore, option D. Question 2. Which of the following cannot be the sum of cards of Guneet and Hansika? Guneet and Hansika, can they be 42? Yes. Can they be 56? Yes. Can they be 77? Yes. But they can never be 49. 49 is a sum only obtained for yellow cards, and Guneet and Hansika were never yellow. So answer is option B. Next, which of these can be the card number of Hansika? So Hansika can have any card number from 7, 35, 49, 14, 42, 63. But she can never have the card number. Oh, sorry. Can be the card number they have asked. She can never be 21 because that is yellow. She can never be 28, that is yellow. She can never be 56, that is yellow. 7 is red. Hansika can be red. Okay. Which of these can be the sum of cards of Chetan Faizan and Ishan. Chetan, Faizan and Ishan. Chetan, Faizan and Ishan belong to three different groups. So I need one number from here, one number from here, and one number from here, and see if I can reach 126. Now 126 divided by 7 is 18. I need three numbers that get into 18. Okay, I see. For 126, the breakdown can be 7 plus 56 plus 63. These three get me to 126. So this is indeed possible. For 98, need 14. So 1, 4, 1, 3, and 1, 4, and 9. So 7 and 28 and 63. This can also get me to 98. So this is done. This is also possible. And finally, for 70, 2, 3, 5. 5 is here, 3 is here, 2 is here. Yes, I can have 35, 21, and 14. So even 70 can be created. So finally, which of these can be the sum of cards of Chetan, Faizan, and Isha? All three of them can be the sum of cards, and that is the entirety of this set. This set is beautiful because it has to be solved in layers. First, you have to identify which card numbers pair up with each other. Then you have to identify which color they are associated with. Then you have to identify which groupings of people can potentially take up every color of cards. And then you have to solve the respective questions. So fun question. Hopefully you learned something.